Hello everyone, I'm Dr. Haseen Ahmed and you are watching Chemistry with Dr. Yousafzai YouTube channel. In today's lecture, we will discuss Barbier reaction. It is organometallic reaction in which different types of metal and salt are used like magnesium, aluminium, zinc, indium and tin. By reacting this different metal atom with alkyl halide, so organometallic compounds are in situ generated, and then this organometallic react with different types of carbonylic functionality like aldehyde and ketone, and as a result different types of alcohols will be the final product. What type of alcohol? Primary, secondary and tertiary will be the final product of this reaction. If we talk about Grignard reagent or Grignard reaction, so in case of Grignard reagent RMGX, this RMGX will be synthesized first, and then this alkyl group are transferred to this carbonylic functionality, and as a result different types of alcohol will be the final product in case of Grignard reagent. So this Barbier reaction is an alternative of Grignard reaction, and in this reaction different types of organometallic compounds are in situ generated which are trapped by carbonyl functionality. So how this organometallic compound will be synthesized first? This organometallic compound are in situ generated by single electron transfer reaction, and then this organometallic react with different types of carbonyl functionality. So if we talk about this type of reaction, so how this reaction takes place, so let's have a look to the reaction mechanism. As we already discussed that single electron transfer are involved in this type of reaction or in the synthesis of organometallic compound. So if we talk about the synthesis of Grignard reagent, as we already discussed that this is Grignard reagent. So this Grignard reagent will be synthesized by single electron transfer reaction. In this case, metal will provide one electron to the halogen atom of alkyl halide, and as a result, halogen or alkyl halide radical will be generated, and in the next single electron transfer reaction, this magnesium metal will be inserted in between alkyl and halogen atom. So this type of organic magnesium halide or Grignard reagent will be the final product for this step. Another reaction mechanism for the synthesis of such type of organometallic compound. So in the previous one, if you talk about this type of magnesium to synthesize Grignard reagent, so here we will discuss or we will talk about general metal atom. So different types of metal we can use in such type of reaction like zinc, indium, and other metal as we already discussed in the previous slide. So in this type of organometallic synthesis, metal atom will provide one electron to this halogen atom of alkyl halide. So this is single electron transfer reaction. In this reaction, one electron will be transferred from metal atom, any type of metal atom which is suitable for this reaction, to this halogen atom, and as a result such type of radical will be generated. So in the next step, what will happen? This magnesium halide will be removed in the form of salt, and this alkyl radical will be regenerated. And in the next step, what will happen? Single electron will be transferred from another metal atom to form such type of organometallic compound. So when this type of organometallic compound are synthesized, or such type of Grignard reagent or organometallic compound are synthesized, then this organometallic compound will be reacted to different types of carbonylic functionality or carbonyl compound. So if we talk about the carbonyl compound, this is the general structure of carbonyl compound R1, and this is R2. So as we already discussed in previous lectures that this type of carbonyl functionality, positive charge will be on carbon of carbonyl functionality and negative charge will be on oxygen atom. So If we talk about this type of carbonyl functionality in which carbon have positive charge, so what type of species will interact with this positively carbon atom? Those species will interact with the carbon atom of this carbonyl functionality having negative charge. So let's suppose if we talk about this nucleophile. Nucleophile is a negatively charged species. So this negatively charged species or nucleophile are any kind of reagent or species with negative charge will interact with this positively charged carbonylic functionality like this one. So I denoted this by dotted line. And another species, if we talk about the oxygen of carbonyl functionality, it is negatively charged, so it will interact with species with positive charge. So electrophile is positively charged species. So this electrophile, if we talk about electrophile, so there are different types of electrophile. It may be in the form of metal atom, or it may be in the form of carbocation. So this oxygen atom will interact with any type of electrophile like this, as we can write it in the form of dotted line. So if we talk about the Grignard reagent in this type of reaction, so RMgX. So magnesium is electropositive metal atom. So what type of charge will be here? So on magnesium there will be positive charge, and alkyl group, which type of bond, which type of charge will be here on alkyl group? It will be negatively charged. So if we talk about this type of Grignard reagent, as we write here in the ionic mechanism, so this alkyl group will interact with this carbonyl functionality. Carbon atom and oxygen will interact with magnesium of this Grignard reagent, and as a result, first this type of this type of four-member intermediate will be produced, and by opening and closing of bond, so this bond is shifted towards carbonyl functionality, and the bond will be break toward oxygen atom, which will form bond with magnesium, and as a result carbon, oxygen, magnesium, and here R, and another R1 and R2 are already attached to this functionality. So this is the salt of magnesium. So after hydrolysis, it will be converted into this type of alcohol. It may be primary, secondary, or tertiary. If we talk about primary alcohol, when this Grignard reagent react with aldehyde like formaldehyde, the product will be primary alcohol. And if it react with aldehyde like other than formaldehyde, the final product or alcohol will be secondary, and if it react with ketone, the final product will be tertiary alcohol in this type of reaction. And if we talk about the single electron transfer mechanism for such type of reaction, so what will be the mechanism for this reaction? So this is the structure of Grignard reagent. In the first step, what will happen? This is carbonyl functionality. So this bond, if we talk about RMG bond, so this bond is made up of two electrons, one from alkyl group and the other one is from magnesium. So the alkyl electron will transfer to alkyl. So for single electron transfer reaction, you must use this type of arrow, and one electron will be transferred toward, it will be transferred to magnesium. Let's suppose we talk about magnesium. So here it is this one radical plus mgx radical. I write this type of intermediate or radical just for understanding, as it is a cascade reaction. No such type of radical will be seen in the reaction, but for understanding I write that such type of radical may be possible. And now what will happen if we talk about this alkyl radical and magnesium radical? So this is positively charged because of magnesium is the metal atom, so it is much more accepted towards electron, and this is alkyl group which possible to attack on the carbonylic carbon or shows interaction with carbonylic carbon. So if I write this species like this and this species like this, so what will be the next step for this type of reaction? As we already talked about that bond is made up of two electrons, so one electron will move toward this oxygen atom and another electron will move towards the carbon atom. So as a result of what will happen, this oxygen, when again one of the electron, so it will be like this and it will form bond with the magnesium. So and when this one electron shifted towards this carbon atom, so it will form bond with this alkyl group. So this is the pi bond break towards carbon and oxygen because it is homolytic cleavage. Homolytic means same breakage of this bond. So if this bond is made up of two electrons, so one electron will be moved towards carbon atom and another electron will be moved toward oxygen atom, and the next bond will be formed with magnesium halide. So when this type of interaction takes place, this type of magnesium salt will be produced, and upon acid hydrolysis or acidic workup, alcohol will be the final product. This reaction is same for both of the reaction, but only a difference is here that it involves radical, and the previous mechanism they involve ionic species. There are different examples for understanding that how or what type of application of this type of reaction. So if we react this type of cyclic ketone with allyl bromide or allyl halide, so it may be allyl halide like chlorine or iodine. So when allyl bromide react with this type of ketone in the presence of this metal atom, same metal atom, so what will happen? So the first organometallic species will be produced. Organometallic species. First organometallic species will be produced by inserting this metal atom in between carbon and bromine bond, and then what will happen? This allyl group will attack at the carbonylic functionality, and this type of alcohol will be the final product. And in the second example, this allyl bromide react with zinc to form organometallic species. In this case, the organometallic species is also produced in situ, which then attack on the carbonylic functionality of this species, and as a result of this type of tertiary alcohol will be the final product. I hope you enjoyed the video, and if you like the video, please like and subscribe my YouTube channel. And if you have any type of question, please you may ask in the comment section. I will answer of all of your questions. Thank you so much.